Hey mathematicians, let's do your homework. All right, so we've got, I think, 3 tables on the front, and we are looking to see what equation matches the table. Now, remember that we are looking for additive or multiplicative relationships, and we need to just watch out because these are not all x and y's. So you need to make sure that you are starting at your independent variable, which is on the top, and going to your dependent variable, which is on the bottom. Now I see 0, 0 right here, and as we discussed in class, if it goes through the origin, whether it's the origin of a table or the origin when it's graphed, that means it's a multiplicative relationship, so that nothing plus 0 makes 0 other than 0. But every number you pick times 0 equals 0. So the point 0, 0 means it's multiplicative, so I'm immediately crossing off my 2 additive options. I want my answer to be my x variable, so I'm guessing it's c because x is isolated, but let's just double check. If I pick a random w, let's say 8, and I multiply it times 3, 8 times 3, that equals 24. That's how I choose my equation that matches. So don't freak out. Again, we've got some interesting numbers. They're telling you in the directions up here that b is dependent, but you should assume that whatever's on the bottom is dependent and whatever's on the top is independent. If you're freaked out by the fractions, then go look at the whole numbers, maybe 10 to 5. Is that an additive or multiplicative relationship? Well, you could come up with an additive rule, and you could come up with a multiplicative rule. Go test it on another option and see what it is. Oh, I was wrong. There are 4 tables. So we're looking again. I don't see any zeros. Oh, the first one was the easiest one because it had a 0. You're starting at negative 18 and you're going to positive 9. That could be because you added 18 plus 9 is 27. Or it could be because you divided by negative 2. So you need to check. I see a divide by negative 2. I see a divide by a positive 2. I see an add 30. No, that doesn't work. And I see a subtract 30. Nope, that doesn't work. So I think you can find it. So what I'm looking for is some kind of evidence that you actually thought about it, not just, oh, I circled one. I want to see you marked up the page, you wrote an additive multiplicative rule, you tested something. On the back, we're back to percents. I saw a lot of people not meeting my expectations on the percents. So to be clear, here are my expectations. I want to see the work of a part whole percent key. I want to see some kind of proportion that you use some of those numbers on. I do not want to see that you wrote a fraction and then stopped, because none of these questions are asking you for fractions. This one is saying what decimal, so I can make a percent and then change it to a decimal. This one is saying what percent. So if you aren't even reading the question to know what kind of answer I'm looking for, then you can expect a West Wing, because you need to be able to read the question and to do the math. But if you're skipping the reading the question part, then you're not even trying. So make sure that you actually read it closely. The shaded area represents the part that he has read so far, which would mean that the white area is the not read part. What decimal represents the part of the book he still needs to read that he has not read? So don't assume that I'm always asking you about the gray part. You need to actually read the question. In that second sentence, in that question sentence, I got 2 main pieces of information. I'm looking at the not read part, the white part, and I'm looking for a decimal version of my answer. So I've got 1, 2, 3, 4, 5, 6 times 2 rows of 6. There are 12 that are not read. Out of 6, 12, 18, 24, 30. Now, I set up this proportion when I thought I was looking for a percent, but I'm not even looking for a percent. I can just divide this to make a decimal. Xavier's buying his family gifts for the holidays. He's been saving money all year long. And the shaded area represents how much he's spent on shopping so far. What percent represents the part he still has left to spend? So again, we're reading closely. You're telling me the part he still has left to spend out of the total number of boxes You're making that a proportion where part goes on top of whole, and you set it equal to the percent, which is always out of 100. Your answer needs to be a percent, and I will not accept oh, I did it in my head, here's my answer. I need to see the work. Tahir found the model below on his math test last year. What value represents the part that is shaded? So you're looking at 4 out of 1, 2, 3 times 1, 2, 3, 4, 4 out of 12. You are making that either into a simplified fraction, because I see that C isn't a fraction, or into a decimal, because A and B look like decimal options. I don't know which one it is, so you actually probably need to change it to both to make sure that you are checking all your options. And last but not least, Brian completed 375 of the 1,000 flips, holy cow, that's a lot, that he needs to qualify to be an Olympic gymnast, to be in the gymnastics Olympics. Which number shows a point that represents this value? Okay, quick gut check. Half of 1,000 is 500. Since 375 is less than that, I'm looking for any dots that are less than halfway through. I'm thinking this one is out just because it's way too far towards the 1. So you have multiple options. Since these are in kind of decimally form, I would probably make 375 thousandths into the decimal version. So you need to check. That's 1, 2, 3, 4, 5. So 1 whole divided into fifths means that we're talking 20ths, or if we needed to make it into the thousands place, 200 thousandths, 400 thousandths. Okay, that's too big. So that's what we're doing. Each of these is cut into different intervals, which means 1, 2, 3, 4, 5, 6, 7, 8. This is 3 out of 8. You need to divide that, change that to a decimal. This is 1 out of 2, 3, 4. 1/4 is a probably common decimal you might actually just have memorized. But the way we solve these is we take the fraction of the dot is the numerator, how many jumps to get to the dot, out of how many total to get to 1, and then we divide that fraction to make a decimal and see which one is equivalent to this.